This video will be beneficial for those of you who were gone and missed the predator-prey analysis when we were working through this in class. So we're looking at a predator-prey graph here, which is showing how wolf populations and moose populations kind of fluctuate or change over the course of time. So with this, the question is, how does the size of these two populations affect each other? With this, we actually have to answer this question. This will be called our claim. So what I see happening in this graph is I see the wolf population, it's kind of changing sizes, it's going up, down, and I need to kind of see what's going on with the moose population kind of along the same time. And I can see that when the wolf population starts to go up, which would be the predator, I can start to see the prey population, the moose, it starts to decrease, which makes sense because if there's more predators, more moose will be eaten. But as a result of the moose population going down, now there's not enough food, I see the predator or wolf population start to decrease as well. When the predator population decreases, now there's less things eating the moose population starts to go back up. And this is kind of a cycle that we see called a predator-prey relationship. So going back to our claim down here, I see two things going on. When this goes up, this goes down, and then when this goes down, that goes up. And that's exactly my answer to this question. How do they affect one another? First thing I see is that I see when the wolves increase, then I see the moose decrease. And then conversely, when the wolves decrease, then the moose increase. And again, let's check that out. When the wolves increase, we see the moose decrease. And then when the wolves decrease, we see the moose increase. So we have answered that question. The next step in this particular assignment that you have is you actually have to use data that proves that this is not just some made up stuff. For the purposes of this class, I really want you to start thinking of numbers when you hear the word data. There's different types of data, but largely we're going to be dealing with data in the form of numbers in this class. And you'll see that there's two data tables. One data table for our first statement and a second data table for our second statement. Because if we're going to say that this is happening, we have to provide numbers from our graph that actually prove that. So let's look at the first statement here. When wolves increase, moose decrease. So I'm just going to make a note here so I know what this is. Wolves increase, moose decrease. So I have to be looking at 2 years in order to really kind of support this. Again, we have the wolves, and we are trying to show that the wolves increase or go up. And the moose, we're trying to show that the moose go down. So I need to find a year in this graph that starts with the wolves being low. We'll call that year A. In year A, the wolves are low, but also in year A, the moose are high. We can then find a second year, we'll call that year B, that shows that the number of wolves has gone from low to high, and also year B, that shows that the moose population has gone from high down to low. These two numbers and these two numbers would support that when wolves increase, moose, they do decrease. So I'm going to go up to this graph. I'm going to see where do I see wolves increasing and where do I see wolves moose decreasing. Well, I see wolves, they start low in 1995, and that's what we're looking for. We're looking for wolves starting low because in order to actually increase, they have to start low and go to a number that's higher. So this is a pretty low number, and this is showing that they are increasing. So I can use that number right there to show it goes from here to here. And in the same 2 years, from 1995 to 2000, I can see that the number of moose go from high, well, down to low. And that's exactly what I'm looking to try to prove. Does that graph right here show wolves going from low to high? It does. Does it show moose going from high to low? It does. Great, I can use those 2 years. So 1995 will be my first year. That's where we started. And I'm going to go to 2000. Next, I have to find how many moose were around in 1995 and how many wolves were around in 1995. So, again, reading these graphs, my wolf is measured on the right side y-axis and my moose is measured on my left side y-axis. So I have to make sure I'm doing this correctly. I have to use the wolf. I have to go over here. So I'm going to kind of just quickly draw a line over to right about there. And I need to figure out what that value is. And I can see that we start at 10. This is 20. That's a little bit more than halfway, so it's a little bit higher than 15. Maybe that's 16 or 17. We'll just call that 17. So that is our wolf population in 1995. So I can go down to my data table. Wolf population, 1995. We're saying 17. The moose population in 1995 was up here. And this scale is kind of hard because it goes up by 480s, which is not exactly the nicest scale to read. So we're going to use some quick estimation over here. All right, so the moose population 1995, this is 1,920. This is 2,400. Let's just say that right there is, I don't know, maybe about 2,100. So 2,100 is what we'll go with. 2,100. So in 1995, moose population was 2,100, and the wolf population was 17. So if we're using this graphic over here, which may help you, year A, there was 17 wolves, and in year A, 1995 in this case, there was 2,100 moose. So we're going to see this number go down. We're going to see that number go up once we go over to 2,000. So in the year 2000, again, my wolf population, got to use the right side. Looks like it was about 30. So my wolf population is 30. And then my moose population, again, got to use the left side. A little bit above 960. Maybe that is right at 960. My line isn't exactly straight. We'll just say 960. So we finished with 30 wolves. We finished with 960 moose. This does show wolves increasing from 17 to 30, which is exactly what we need numbers to show. And these two numbers show moose decreasing from 2,100 to 960, which is exactly what we need to show. So we have these 2 years and those 4 data points, numbers, that show that when wolves increase, moose decrease. The last step to this is to provide a written explanation of how these data points prove that this statement is correct. We have our statement, we have our numbers, but now we need to say this is why our numbers show that we're actually correct. I provided a pre-generated written kind of fill-in-the-blank type of thing to kind of assist with this as we kind of start to acclimate how to write this stuff. So we're starting with data table 1, which is what we were looking at. And we started in the year 1995. It shows that in the year 1995, that's where we started, that the moose population was 2,100 and the wolf population was 17. But in year, and what's the year we finished in? It was 2000. The moose population, did we see the moose population increase or decrease? Looks like it decreased. So I'm going to actually cross out or delete the word increased because it did decrease. On your computers, you can delete that word. It did decrease to, looks like 960. And what did the wolf population do as a result? The wolf population looks like it had increased to 30. So the wolf population had increased to 30. Now, again, what this is showing us is a written explanation as to how these numbers actually prove and support the idea that when wolves increase, moose decrease. This is what we talked about in class if you happen to have been absent. If you were gone, this assignment is in Teams. Your task is to kind of use this idea, complete data table number 2, to support idea number 2. When the wolves decrease, the moose increase. So wolves decrease, so the moose increase. That's what you need to show. So up in our graph, you need to be thinking about, okay, what are 2 years that show wolves going from high to low and the moose going from low to high? Give me those 2 years. Give me the moose population and the wolf population of those 2 years so you can actually show decrease and increase. And then you can take this data and you can plug it in to the second short little paragraph that is underneath the first one. Once you're done with that, you can submit the assignment. I'll check it out and give you a grade for it. I do want you to know that I don't expect you to be pros at this yet. This is simply practice to get better. Never going to get better if you don't go through repetitions. And do know that I will be giving you feedback to kind of guide your thought process in the event that you might need a little bit of guidance. Reach out to me if you have questions.